Newton's second law is definitely the easiest one to understand, but it is by far like the most used. We will use it all year long. In fact, I have a few friends who say that if you know Newton's second law, you know all of physics because you could pretty much derive a lot of equations from Newton's second law. So let's get right to it. Newton's second law says force equals mass times acceleration. We measure mass in kilograms. We measure acceleration in meters per second per second. And so you could measure force as a kilogram meter per second, which would be in its base units. But that's too miserable to use on a daily basis. So we just name it after Isaac Newton. And so force is measured in newtons. If you were in America, you might measure forces in pounds, but we don't do that. Like that's just not done. We measure forces in newtons or kilogram meter per second squared. All right. Now, like I said, there's not a whole lot to say about Newton's second law. F equals ma is the whole thing. So I can flesh it out a little bit and say that, look, there's an inverse relationship between between mass and acceleration. So when you have a force acting on a small mass, you get a big acceleration. And if you have the same force acting on a big mass, you get a teeny acceleration. So mass and acceleration are inversely related. If the mass is big, the acceleration is small. All right. Now, contrast that with the direct relationship between force and mass. So if I want to keep my acceleration the same, then if I have a little mass, oh, my fingers are all backwards today, then I need a little tiny force. And if I have a big mass, I need a big force. So that's pretty obvious. Like if I want to throw a ball with an acceleration of say 1 meter per second, then if I have a little ball, I'll just need a little force. And if I have a huge boulder, I'm going to need a huge force to get the same acceleration. Those are a direct relationship. And then last but not least, there's another direct relationship between force and acceleration. So let's say I keep my object the same. I keep the mass the same in both cases, mass and mass. If I use a little tiny force, then I will get a little tiny acceleration. And if I use a big force, I will get a big acceleration. So if I have my car is broken down and I want to push it out of the way, then if I use a small force, then my car will accelerate at a small rate. If I use a huge force, like if I just ram it with another truck, then I'll get a big acceleration. So there's a direct relationship between force and acceleration. Again, second law. You're multiplying two numbers, mass and an acceleration, and you're getting a force, one of these directions. All right, that's about all there is to say.